Hello everyone. Today we're going to be looking at day 2 of solving systems of equations by multiplication. These questions can be kind of tricky, so we definitely want to make sure that there's a second day spent on this and another example for you to reference. So let's get started. Systems of equations multiplication. Solve the following system of equations. So we have x minus 5y equals 5 and 3x plus y equals 31. I'm going to ask myself those 3 questions from yesterday's PowerPoint. Do I have inverses here? No. Do I have identical terms here? No. And do I have an equation in the form of x equals or y equals? No. So I know I'm going to have to do something to create a set of inverses here. So I have to find which equation I can multiply by which number so I have a set of additive inverses. That is the goal. So I'm going to focus right here. There's a couple of different ways to do this question, but wherever I see a variable without a number in front, I'm going to just put the 1 there so I know that I have that coefficient of 1. Now, the LCM of our x coefficients of 1 and 3 is, actually I'm going to get rid of that a second. I don't want to make it too confusing. Okay, so the LCM, I'm going to look at the coefficients for x. The LCM of 1 and 3. The smallest multiple that they both have in common, and if you want, you can list this out, 1, 2, 3, 4, 5, and so on, and then 3, 6, 9, 12, and so on. You'll see that their least common multiple is 3. Okay, so the least common multiple of 1 and 3 is 3. I'm going to just erase these multiples so I have space below. And then let's look at the y values here. So the LCM of 1 and 5. So notice I'm just taking these numbers in front. I'm not paying attention to the signs, just the coefficients. If you list out your multiplication tables, the LCM of 1 and 5 is 5. Okay, so what we can do is we can multiply this equation for these to cancel out, or we can multiply this equation for these to cancel out. So this is already a 3. We wouldn't want to change this equation if we were focusing on this LCM. But you have to ask yourself, okay, what can I multiply this term by for this to become a negative 3? Because remember, we want them to cancel out, so 1 has to be positive and 1 needs to be negative. So that's the first question you can ask yourself. If you want to focus on the y values, say, okay, this, remember, our LCM is 5. This is already a 5, and it's negative. So we can ask ourselves, okay, what can we multiply here for this to become a 5? So those are the 2 different approaches that you can take. As long as you do everything correctly, you're going to get the same answer. So I am going to focus on the y values here. Why? Because this is negative and this is positive. So I won't have to multiply by a negative number because I already have opposite signs. If I was focusing on 2 positive terms, I would have to multiply by a negative number, and I don't really want to do that. I want to try to avoid changing signs as much as I can. So I'm going to keep this first equation the same because this is already a negative 5y, and then I ask myself, what can I multiply this by so it becomes a positive 5y? So basically, you can take that LCM and divide it by the number in front. That's going to give you the number that you should multiply by. And the number is 5. So I'm going to multiply this equation by 5. So watch what happens when I do that. I'm going to just erase this so I have enough space so it doesn't get too confusing. Okay, so I'm going to rewrite my equation after I multiply each term by 5. So I have 15x plus 5y equals 155. Okay, so that's what this equation became. I multiplied everything by 5. Now, I didn't change the first equation, so I'm going to just rewrite it. So I'll keep that 1 there if it's going to help you. Okay, so now we have a set of additive inverses here. Once we have that set, we can solve it as if we were solving it, like as if we didn't have to do that first step. We're going to add these together. Here's my additive inverses. They cancel out. 15x plus 1x gives us 16x. And then 5 plus 155 gives us 160. Divide by 16 on both sides. And you get x equals 10. So that's our first value, x equals 10. I'm going to put that right here because I am going to erase this just so actually I could probably fit it on the side. I'll do it on the side. So x equals 10. Remember, this is a system. We have to solve for x and for y. So I'm going to do that right here. And I'm going to just take the equation that we didn't touch, but you can choose anyone as long as it's not the original, not the one that you changed over here, as long as it's one of the originals. So I'm going to do x minus 5y is equal to 5. And I'm going to take my x value and plug it into that equation to solve for y. So instead of writing x, I'm going to write 10. And then everything else stays the same. Minus 5y equals 5. Subtract 10 on both sides. That cancels. 5 minus 10 gives us negative 5. I'm going to bring everything else down. Divide by negative 5 on both sides. And we get y equals 1. So our answer here, so y equals 1, as an ordered pair is 10, 1. Okay, so just to refresh, I know it was a little, there was a couple different things we could have done here. I wanted to just make sure that you guys knew exactly that there's 2 different ways you can solve this. You could have multiplied this first equation by a negative 3 to create these inverses, negative 3x and 3x. Or we could have multiplied this bottom equation by 5 to create inverses of negative 5y and 5y, which is what we did. Multiplied everything by 5. Then we had our additive inverses that can cancel out. Add your equations together, solve for that variable. And then whatever variable you get, you're going to plug into one of the original equations to solve for the other variable. Write your answer as an ordered pair. Hopefully this will help you, and the more you practice this, the better you're going to get.